Hello for everyone. Today I'm going to show you how can we develop a control process with using pchart and pchart, and how can we develop also pareto chart. So in pchart, you don't forget pchart and uchart are for attributes. So in first I'm going to upload my data. Yes, like this. He gave me the possibility to upload my data. The first one is this one. So I'm going to take a look for my data. As we see here, we are the samples and the defects. The samples are equal, as you see here. There are 15 in all the cases to 21 cases. So it's very easy to do that. I'm going to attach and name is my data. So when we want to develop pchart, a control process with pchart, I I recur to QCC package. So if I if I don't have QCC package, I go to tools and install it in my computer. So I do like this QCC, and I have to define my data. The name of my data is data, okay, and the type which I want is P. In this case, the size, I must define the size. The size is equal to 15. When you look here, all the samples are 15. So I go and I must 15, and I execute my. There is a mistake here. He don't give me the output because here I do a mistake. But when I am interested for the defects and not for all the data, so I just return here and I define my data. So the data is data defects and not all the data. Okay, that's which I get. I get my p charts and the central limits, the standard deviation, the upper control limit and the lower control limit. Don't forget, pchart is interested with the proportion. So there is another kind of control process with pchart when the samples are not equal. So I have to copy this, but I'm going to change my data here. Okay, to change my data, I'm going to upload another data when the samples are not equal. As you see here, the samples are not equal. Here I have 15, 35, 15, 40, 48, etc. So I just go in this line, and because QCC package it's installed in my computer. So here we have we are always interested for the defects, but the size is the numeric value of the sample. So I'm going to say like this: data dollar and sample. Why I do that? Because that means take the size of the sample, take it as the one numeric of the samples. Okay. So when I run this line, I get this this chart. As we see here, the size are not equal. The size are not equal. Every sample has a size. That's which we say it here. The lower control limit is variable and the upper control limit is variable. But he gives me the center and the standard deviation. So this method, we called it with control limits. But there is another kind where I can also take all just the average. That's the average of my data. Yes, when I look, when I want to calculate, because here, as you see here, the samples are not equal, I'm going to return here first, and I'm going to say, give me the data one, all the data one. Okay. In this time, I'm going to take the average of the samples. So I say the mean of data one samples. He give me the mean of my samples. So I return in this line and copy it. I'm sorry. copy, and in this time the sample is 24.28571. I define my QCC data is data. It's not data. It's data one because the name of my data is data one, as you see here. I'm interested to draw the defects with TP size is like this. And I get my chart here. This time he gave me the upper control limit and the lower control limit with the standard and standard deviation. So that's all for P chart and MP chart. I'm going to show you now how can we upload Pareto chart. Pareto chart. So Pareto chart is also it need the QCC, but when we install the QCC, we just write Pareto chart, define. I'm sorry, first I'm going to upload another data for Pareto chart because Pareto chart is interested for the defects and the defects. So the causes of these defects. So I'm going to name my data 2, but before I must upload it in my computer in RStudio. I'm sorry. What is it? Yes, this one, and I get it. So the samples now are not a numeric variable, but they are the causes of the defect. The factor 1, factor 2, factor 3, and etc. Or for all the data. So when I say Pareto chart because it's interested for the role 80% and 20% of the causes of the defects. So I'm going to say data 2. Automatically I'm interested for the defects. So when I run this line, I get the Pareto chart as we see here. But I can also change this variable C, H, E, D, B, G, E, F, E, G. Do the same work. Pareto. Yes. In this time, I'm sorry. It's data $2 defects. Name is equal what? Because there is difference between claim and claim and name. Name is that mean give me the names of all this. The names it's data 2 because I'm interested in data 2 now of samples. What means that? As we see here, the samples are the factors. So I give him the order to take the numeric value or the numeric. They are not numeric value. Or this value, factor 1, factor 2, as the names of the chart, and I take OK all, and I get my factors. So now I'm going to take copy this output, and I go to paint. I'm going to put it here. Yes. As you know, the Pareto chart it's the role of 20%. I'm sorry about my language. It's not very. I'm not very fast in English. So that is the role of Pareto chart. When I go and define here the 20%. And do the same projection in factor 7. All those party is considered as 80%, and this is 20%. So all the defects are caused by factor 1, 2, 3, 4, 5, and 6 until 7. Until 7, that means the 80% of defects. I'm going to go. Remember at my this one here, factor 7. Okay. When I go to factor 7, and I look at just until E, that's represent 80% of the device. So that's the method to how to plot, or how to control the process of production of any management in our firms with P-chart. That's all for today. Thank you for watching. I'm waiting for your comment, and thank you very much. Okay. Thank you.